All right, hey AP Chemistry. So I got a question from Madison about question number 4. So I figure maybe if I get us a little started and help on doing question number 4, it might help us with being able to answer questions 5 and 7 for your homework. Now remember, in chapter 15, the big thing that has been introduced is this ICE table, and it's very similar to the BCA table. So if we read question number 4, it says chlorine molecules will dissociate at high temperature into chlorine atoms. So maybe it has to do with the vocabulary, but a molecule is kind of like that little thing with the 2. This is a molecule, Cl2 is the chlorine molecule, and that's a gas. And at very high temperatures, it will dissociate into chlorine atoms. So let me just fix that a little bit. But the atom is the one point of the element, or one element. So an atom is one element. Molecule could be 2 of one element combined. So remember, molecule is more than one atom. So it says the dissociation at high temperatures into chlorine atoms, right here. At 3,000 degrees Celsius, for example, Kc is shown, for the equilibrium is shown, is 0.55. So Kc is 0.55. So they gave you the equilibrium constant here. It's 0.55. So now it says, if the partial pressure of chlorine molecules is 1.5 atmospheres, calculate the partial pressure of the chlorine atom. So there's a couple of things here involved, okay? You have to remember this is a way to compute between Kc and Kp. Kp involves an expression that uses all of the partial pressures. So let's start by first writing the Kp expression. The Kp expression uses the partial pressures, or just letter P. So it's the way that I write a Kp expression is I use the partial pressures of the products raised to some power over the partial pressure of the reactants raised to some power. I don't know why my P came out a little bit weird here. So that's how I'm writing my Kp expression. If I want to write a Kp expression for this, my Kp for this reaction would be, I have 2 of my products, so my pressure of my Cl squared over 1 reactant pressure of Cl2. That's how I would write my Kp expression. Now, the problem here is they gave us the Kc. From our entrance task and from what you know from section 15.4, I am able to calculate between Kc and Kp. Kp is equal to Kc RT raised to the delta n, if you remember from our entrance task. So what's going to happen is I'm going to have to get my Kp, and then the rest of the question, I didn't even get there. It says if the partial pressure of the chlorine molecules is 1.5 atmospheres, so I have the partial pressure of this. It says what is the partial pressure of the chlorine atoms? So I will have this in my expression. I will have this. I'm going to be solving for this. Before I do any type of solving, I need to solve for my Kp. Now, remembering from our entrance task from 2 days ago, my R value, I'm going to go back to my gas constant. So it's 0.08206 liters times atmospheres per mole Kelvin. My temperature, it told me that my temperature was 3,000 degrees Celsius. Now, my temperature needs to be in Kelvin, so I need to add 273. And I'll get 3,273 Kelvin, right? So that's the temperature for this problem. And then my delta N is my moles of my products minus my moles of my reactants. And so if I look at this question, and might not be able to see this, I have 2 products and 1 reactant. And only 1. We use the coefficients, basically. So my delta N is going to be 2 minus 1, which equals 1. My delta N is equal to 1. I have 2 products, 1 reactant. Now all I have to do is plug in these numbers into this equation. My Kc is 0.55, so let me do this math over here. My Kp, again, is Kc RT raised to the delta N. Kc is 0.55. My R is 0.08206 liters times atmospheres per mole Kelvin. My temperature is 3,273 Kelvin, and that's all raised to the power of 1, which is itself. Now, if I go and get my calculator, if I go and do this math, I'm just going to have to do 0.55 times 0.08206 times 323, all raised to the power of 1, I'm good. So 0.55 times 0.08206 times 3273, and I get my Kp is equal to 147.7. That's what this number is. Okay, so in this problem we have to do a couple of things. We will be doing a couple of things. I need to calculate Kp. If it wants anything to do with the pressures and not the concentrations, I need to use my value of Kp. And my Kp is just like my Kc, except it uses the partial pressures instead of concentrations. And so now my next step is the question asks for if the partial pressure of chlorine molecules, if the PCl2 is equal to 1.5 atmospheres. So the partial pressure of chlorine molecules, remember this is a molecule and this is an atom. Atom by itself, right? Molecule together. Okay? If my partial pressure of my chlorine molecules is 1.5, what is my partial pressure of the chlorine atoms? And so all I'm doing now is I have my Kp, I have my PCl2, I'm just looking for PCl. So I'm going to plug in my numbers. Okay? So I'm going to plug in my Kp is 147.7. So I'm going to do all of this work down here so we can see it. So Kp is equal to PCl squared over PCl2. Kp is 147.7. My PCl squared, I don't know yet. Right, PCl squared. And then my basically it's squared, right? So we know that. Partial pressure of the products raised to some power, right? And my PCl2, or also known as my partial pressure of Cl2, is given to me as 1.5. And now, remember that our Kp and Kcs are unitless, so I do have atmospheres, but those units are going to go away. Now, all I'm doing is algebra. I'm trying to solve for PCl by itself. So if I want to do that, first I have to multiply 1.5 times 147.7. This is math. If I'm trying to isolate the PCl, I got to multiply both sides by 1.5. So 147.7 times 1.5, and I get 221.55 equals PCl squared. And now if I want to solve for PCl, I have to do the opposite of squaring, which is getting the square root of both sides. So my partial pressure of my chlorine atoms will be the square root of 221.55, which is equal to 14.88 atmospheres. And that should be my answer. Now, it's not in the correct sig figs. If I want to have the correct sig figs, I was given 0.55 and 3,000 degrees Celsius. Technically, I should have one sig fig, so I might just be at 20 atmospheres. But without sig figs, I'm going to say my answer is 14.88 atmospheres. Now, I put the units back, but the question is asking for the partial pressure of chlorine. And my units for pressure need to be atmospheres for these type of calculations. So question 4 was a bit involved, but I've walked us through going through all the things that we need to know. Question 4 didn't really involve an ice table, but we did need to know how to write the Kp expression and use Kp to solve for our partial pressure. So don't forget two things: converting Kp and Kc, And the other thing is knowing how to write our KP and KC expressions to solve for any unknown. Let me know if you need any other questions with 5 and 7. 5 and 7 ask you to use an ICE table, so you will have to use an ICE table to solve for concentrations at a certain point in time, okay? You could have used an ICE table for this, because if I set it up, I'd be looking for a certain variable, but we could talk more about that when we get to section 15.8. Let me know if you have any other questions, comments, or concerns. Hopefully this will help you. Make sure you get this work done by the next class day.